This video is a quick introduction to the use of personal instrumentation in electronics courses at RPI. I'll begin with a little bit of history, particularly my personal history, and then talk about the application in two courses. One is a course for non-majors, and then the second one is a course for first-year ECE students that was just developed over the last year. In this slide I show a little bit about my own personal development as an engineering educator. I began getting involved in studio instruction in the 1990s, where we took an idea from architecture and the arts to combine everything that a student would be exposed to in multiple classes, like lecture classes and labs and recitations and so forth, into exactly the same classroom. And so we created special studio classrooms that involved laboratory apparatus, computers that had simulation software on them, good audio-visual capabilities and everything. And the idea worked really well. It was great to be able to do exactly what was the appropriate educational activity at the time, whether it was a short lecture or an experiment. Unfortunately, it just didn't scale because we were using desktop instruments, and so it was too expensive and we couldn't do it in anything except a special purpose classroom. And so we had to figure out a way to make this happen anywhere, anytime, and came up with the idea of the mobile studio. Mobile studio was a small board that had all of the capabilities of standard desktop instruments. I have more to say about that in just a second. And that allowed us to do studio instruction anywhere. After studio instruction got established, about the same time as flipped classrooms became a popular topic, and with the motivation provided by some excellent colleagues at other universities, I decided to flip this classroom and had really good results by moving all the lectures to YouTube and spending all class time just focused on hands-on activities with the students. Ultimately, as has happened in the engineering education community in general, recognize that this is really what should be called blended learning, where we combine lots of different kinds of learning modalities in the same kind of environment. Because I kind of jump from one thing to another and keep making major changes in the way the student learning experience is provided, call this punctuated equilibrium, kind of inspired by one of my favorite science authors, Stephen Jay Gould. Okay, so what are the two courses? Before I get into that, I want to mention one quick thing, and that is at RPI we don't have an ECE department, we have an ECSE department for electrical, computer, and systems engineering. I'll use the terms interchangeably. I prefer to use ECE because it's more generally understood by most of the engineering education community. So the first course is Electronic Instrumentation. It's a broad course in electronics for engineering students outside of ECE. That means it's mostly mechanical engineers. There's 2 sections per semester of 60 to 80 students each. We did have a new instructor a year ago. Previously, I had been teaching most of this course for quite a while. We began using Mobile Studio, and now we use digital and analog discovery. So this began as a studio classroom in the fall of 1997, ultimately evolved into a mobile studio classroom plus a lecture. When I took the class over in the spring of 2010, I flipped it, so I moved all of the lectures to YouTube and made everything in classroom focused on hands-on activities. Very, very little lecturing goes on in class now. In spring of 2014, we switched to analog discovery, and future hardware may also change. In the new course, it's very similar in the way it's laid out. It's an introductory course. It had 2 pilots this last year, as I mentioned, and its planned steady state will be 3 sections per year, not 2 per semester, and about 60 students per section. The studio instructional model, the way I like to lay it out, is shown here, which combines the traditional fundamental lectures, paper and pencil problem solving, that sort of thing, with experimentation and simulation. And the goal is to create some kind of a system model that allows the students to understand how a basic system works, such as operational amplifier, or to design some kind of a widget The goal is to make the student experience in electrical engineering as close to that of a practicing engineer as is possible. In this slide I show what the mobile studio looks like. For those of you who haven't seen it previously, here is the mobile studio right here. This is the board we developed at RPI, and it's similar in size to Analog Discovery if you're used to seeing that now. It's a complete electronics anywhere, anytime. And Sam Fuller of Analog Devices has called this personal instrumentation. He was actually the first person I heard use that expression. I like that because it's a great way of expressing the fact that we put the tools in the hands of the students. Now we use the Analog Discovery board. We could have used MIDAC. Analog Discovery seems to have better frequency response for electrical engineering applications, so this turns out to be a better choice for our students. MIDAC would be fine, I think, for the mechanical engineering students. I think our desire to use a single platform was primarily what caused us to choose Analog Discovery for everyone. We'll be continuing to evaluate this and looking at new boards in the future. Okay, I did want to mention some of the people whose work I have taken advantage of in developing this course, and particularly with the idea of flipping the classroom. With the flipped classroom, John Bosky from Wisconsin and Cindy Firth from Utah have been an inspiration, and Bonnie Ferry's recent work with her MOOC, which is for a course very similar to the electronic instrumentation course that I teach. And then, while her name's not on here, also Kathleen Meehan from Virginia Tech, whose Lab in a Box project also has provided me with a lot of good information for my courses. For more information, I recommend taking a look at the recent ASWE meeting. There were multiple sessions that addressed topics of interest, and they're all listed here. Previous ASWE meetings also have relevant papers. So the existing course had 8 experiments, 4 projects, quizzes, many of the usual things. What wasn't usual, of course, was that it was flipped and all of the lectures were on YouTube. But the thing I think that has been the most fun has been the checklist. This is a reflection activity that the students go to where they present what they've done on at least a subset of the tasks for each experiment. And this is done with one of the instructors or teaching assistants and the team, and they have to present what they were trying to do and how the data that they've collected actually supports the goals of that activity. They're not given credit for being able to follow directions. It's all how they can utilize the information that they've collected from their experiments, from their simulations, from their paper and pencil problem solving, and that all those are shown down here again with the engineering design process model that I had on a previous slide. And then we provide them feedback so that we can understand best what it is they understand and what they still need to work on. This has been a great way to learn about what they do know, and a great way to help them identify barriers in their learning and address them and move forward. Student learning has been remarkably good in this class. The new course has a similar structure, except for a couple of actually major differences. Rather than 8 experiments, there's 18. We thought it best to use more bite-sized activities with the first-year students. But the thing that has been a real important part of this is that I've spent a lot of time working with high school teachers to identify what it is the students should have learned about electricity and maybe even a little bit about electronics in high school and earlier, and allow them to go through those activities with the new tools that we provide them with, Analog Discovery, with LT Spice for simulations and so forth, so that they can actually do these things right and learn what they had learned previously at a kind of a shallow level much more deeply, so they get a good base for future courses in ECE. All this material is available online. I do everything totally publicly, so if you go to either one of these websites, the first one is for the first year course and the second one is for the non-major course. Everything is there except for the few homework assignments that are on the Blackboard LMS system, and I encourage you to take a look at them and send me any questions or comments that you may have, and I look forward to talking with you more about this in the workshop.